Okay. So, all right. So we're back on it. We had our break. We're talking about the need for software engineering. All right. So we said here that, of course, software engineering as a concept came about. Software engineering as a concept came about because of the of course the rate of change in the requirements and the environments that software has to work in. And additionally, we have some of the needs here. We have large software. Okay, so we saw that there's a you know software is big. Some software projects are thousands, tens of thousands of lines long, right? Operating systems are huge. Some enterprise level software is huge. Even some web software, some of them, some websites, they're really, really big. It's not possible, right? It's not possible to have one person manage all of this. Okay, it's not even possible for one person to have to build all of that. So, they say here if you're just building a wall, that's fine. If you're building a house, that's manageable. If you're building like a building, however, like a skyscraper, you know, it becomes very difficult to manage. And so you're going to need some sort of project management to deal with that in general. You're going to need some project management to deal with it. And you need to take that structured approach. Next up, we have the scalability. Okay. If you think about what you're doing beforehand, it is very, very likely that you are going to build it in such a way that you can make changes to parts of it without affecting all of it. So the engineering aspect is what uh, works with that, right? You don't want to have to recreate new software. Sometimes, and it's been done, even for very large software throughout the history. Again, do not get it wrong. There have been instances over the history of, let's say, operating systems. I like to use operating systems as an example because everybody can relate to operating systems. But over the history of operating systems, when Windows was moving from a DOS-based system to newer technologies, they would have rewritten most of the operating system. But what they would have gotten in terms of the scalability aspect there is that you take the parts that worked from the old operating system, and even if you have to rewrite it, you have essentially a blueprint for your newer operating system. So it's easier to recreate, right? If you didn't do the proper things, it's easier to recreate something new than to scale an existing one. And if we stay with the building analogy, all right, sometimes you ever I don't want nobody put up the hand, but you ever went to somebody's house and you wonder, well, why is this house laid out in this manner? And it might have been that the building of the house, while the building itself is fine, the person who built the house probably just kept on adding a room here, adding a room there. They did it by themselves, so they get something to work, rather than somebody who might have had a plan for what they were doing beforehand and said, okay, I'm going to build this house in such a way that when I want to renovate, I could add 2 rooms and turn this previous room into like a study or a TV room or an office, and the house still has a nice flow to it. Rather than, I know somebody whose house is like that. I'm not going to tell you who it is. It's not my house, eh? All right? Not my house. My house is small, but it makes sense. Right? But the person's house is large, and you could see where the original house was, and you could see additions to the house, and you're kind of like, well, this is a kind of weird place to just be sitting down in the house as, space and So software engineering is the same concept. If you plan out what you're doing, it becomes easier to scale, even for problems that you are not aware of as yet. And that is a huge, huge, huge consideration that you must make for your software engineering products as well. Okay? In the event of the unforeseen, how easy is it to add a module to this, whether or not we can foresee or not foresee, right? Of course, if you can't foresee it, there's a additional layer of difficulty. But what you have to consider inside of there is the fact that at least there is the ability to improve on what you have created. Cost. All right, cost. So the hardware industry, in terms of manufacturing, the more manufacturing takes place, the lower the price of computer and electronic hardware. But the cost of the software remains high. Why? Because the cost of building software is something that is, again, it's a specialized. And it comes back to the title of this class. Okay, developing software is not simply something that if you throw more people at it, it's not going to make the process any easier. Because sometimes, the more people you have, the more complex the project becomes. Because now you have to assign responsibilities to everybody, and you also have to ensure that everybody who is assigned to a responsibility is doing what they have to do, and what they are creating can integrate with what everybody else is creating. So has anyone here ever heard the quote, a person is smart, but people are stupid? Anybody ever heard that?
I see a lot smart that one.
No,
Right?
no.
Yeah. A person is smart, but people are stupid. And what that means is not just, don't take just that the people are stupid, but people unorganized tend to cause chaos. Right? Look it up. It's a well-known theory that unless you have somebody or a group of persons coming together and making a deliberate plan, then any group of persons who just decide to do an activity is probably going to end up doing it in the most chaotic way possible. And it's amazing because the flip side is true for a lot of animals, right? An ant by itself is pretty dumb, but a colony of ants is like a whole working brain system, right? A wolf by himself could feed, but a pack of wolves is an efficient hunting organization. But when it comes to people, you have smart people, but you have smart persons, but people as a group need direction. And the thing is, taking the wrong approach to software development, especially when it comes to putting people into the project, can cost more in the long run, right? Again, I cite the book I cite the book this by the same person, Frederick Brooks, who I took the quote from today. Okay, the book The Mythical Man Month. And I suggest that as anybody who wants to go into either project management or software development, read that book, The Mythical Man Month, along with the book Algorithms for Living, right? I can't remember who wrote Algorithms for Living. But those books, especially as you guys are young, those books make a lot of sense for you to expose yourself to. Okay, and they're good books for life in general. Eh? Any field that you go into, you can read those books, and the concepts that are discussed in the book, you can read the book casually. Don't read the book for study or anything. So read the book casually, right? And there's a lot that makes sense in those books. But as I go back, I'm saying what Frederick Brooks was really talking about was the fact that if you have in terms of software development and you put more people, it's actually going to extend the length of time it takes, because there's time that it takes time to get to consensus for certain things. Next, we have the dynamic nature of software. Software always growing. We have to adapt to the nature of the software. It's the environment in which the user works. And when we say environment, we can mean what works in one territory is not going to work in another territory. Why? Because Trinidad laws might not be the same as the United States laws or Canada's laws, right? They might not be the same as China's laws. And one example that I love to cite for this is Uber. Why did Uber fail in Trinidad and Tobago? Can anybody tell me? Can anybody guess?
So, and they killed one of the Uber drivers.
Well, in terms of, well, that doesn't happen alone in Trinidad and Tobago. Eh? That's a problem that happens in a lot of places in the United States. I was actually talking to a friend of mine online, and she was telling me that she wanted her husband to stop driving Uber because that's a common problem, that Uber drivers get robbed and killed all over. And that wasn't the break factor for Uber in Trinidad and Tobago. The breaking point for Uber in Trinidad and Tobago was that actually Uber's business model runs afoul of Trinidad's licensing laws. No, people in Trinidad can't just pick up and decide I'm going to drive taxi today. Yes, it have people who does pull bull, and that is be like just on the side, small thing. But for a business to come and say, okay, we want to arrange a system in such a way, and I'll show you all where this is problematic. Eh? The organization to come and put in a system where it actually facilitates running afoul of the laws of Trinidad and Tobago, because to work taxi in Trinidad and Tobago, ideally you should be registered with the Ministry of Works and Transport as a taxi driver, right? And you need to have a license, your taxi badge. So Uber, whereas in America, once you have a car, there's no special alternative need for you to do anything else to really run a taxi service. But once you plying your vehicle for hire in Trinidad, you're supposed to get the appropriate insurance. You're supposed to get the registration with the Ministry of Works and Transport. And I'm saying that culturally, people have not done that. And people don't get hold for it, because we know that there are some communities in Trinidad and Tobago where where taxis just don't run, and everybody using the PCAR to run taxis. But in terms of having a multinational organization do it, in the face of the laws of a particular country, it could not stand. And the irony is that there is another company that does the same in Trinidad and Tobago, right? That allows you to share rides. And nobody but this company is a local company. No, so we treat it as our culture. But the thing is, Uber would have run afoul and could have caused, an incident. Who looking for the person in Trinidad who running the same scheme? Nobody, right? So in terms of software, even those things have to be considered. The environment being the laws of the land, and the requirements for the software. So that's something that stuck it all together. There might be some things that change how it's getting done, right? If the nature of the software is changing, new enhancements need to be done in the existing one. So sometimes, let's say for instance, a new tax law comes into place, or a new worker regulation comes into place. You need to have that reflected in the software that is capturing information on either the finances or the working hours or the login of the system. And you're going to have to change that in your software. So this is where software engineering plays a good role, because again, if you take a nice structured approach, an approach where you look into what is required for this software, you design the software and code the software in such a way that things can be changed without impacting too much of the overall code, but still be efficient and effective, and the code still be reliable. And you have your testing, and you have your appropriate documentation, etc. Okay? And then, of course, lastly, we have quality management. And, once you manage the process to create something properly, once you manage the process to create something properly, you are going to end up with a good product. Okay? You're going to end up with a good product. So we have that. And the last things that we want to talk about is some characteristics of good software. Okay? So we have some software characteristics, right? We have operational characteristics, transitional characteristics, and maintenance characteristics. Okay? So once we look in terms of how the software works, right? How the software works in operation, we can measure software based on the budget, the cost of the software. How usable is it? How efficient is it? Okay? And we actually using a piece of software even to have this meeting right now. That might not be the most efficient in terms of computer resources, and it's kind of funny, because but if you think about it, it was not initially intended for this purpose. Okay, Teams would have been intended for more corporate use, where persons would have put a lot more investment into the machines that they might have bought, so that the machines can run the software. Teams, because Teams uses up a lot of RAM on your computer. Teams is resource intensive. I think Microsoft is working towards making it better. And again, this is software engineering in action here, right? And then there's also the web interface as well. But Teams was, for the original use case, Teams was efficient enough. Teams was efficient enough. Now you have students with lower end computers that need to access Teams. You have students with lower end computers that need to access Teams. And what happens now is that Teams comes like a resource hog on most people's computers. So, it's again, a lot of these things are relative. Okay, is the correctness in terms of, is this the appropriate software functionality, dependability, security of software? We spoke about that a bit in the beginning, especially looking at with the example with the English healthcare service, and safety of the software. Does the software, maybe the software has to control some sort of hardware? Are there fail safes in the software, so that in the event that something goes wrong or out of plan, that persons don't lose life or limb? We have transitional aspect of the software, where we looking at it from one platform to another, right? Because again, I'll stay with Teams, and I don't want to be bad talking Teams while we are on Teams. But portability is great on Teams to an extent because you can access Teams on your Android phone, your iOS phone, on a Mac, on a PC. But if you're on a Linux machine, Linux, who Microsoft just embraced but refused to make products for, you kind of left out only to use the web interface for Teams, right? And this is because Microsoft wants to use the best of Linux without really giving anything back to the Linux community. Because Microsoft doesn't want, especially with Linux being a free operating system, Microsoft doesn't want to put products on Linux that will make Linux be an appealing choice for too many people. Okay, so we use what we can from Linux, and we give them not too much, not enough to make people comfortable using it. Interoperability. How do we ensure that one system and another system's what is produced on one system will work on another system, right? Clay might create a Word document on his phone. Ryan might have a iPhone. Clay might have an Android. Okay, Kalika might have a MacBook. Alicia might have a Linux machine. Alicia might be out in the cold with a Linux machine with whatever was created because maybe the support wasn't there for that system. But Clay, Ryan, and Kalika can move their file between their systems within their software, and everything will work as is intended. Okay, reusability. Reusability is in terms of code. How much of when I build my code for one system, how much work do I have to do to make it work on another system? Adaptability. Adaptability is very similar to that. Adaptability, how if I have to move from one system to another, is it an easy integration for me or not? And we're talking about, remember, using the same software. Right? We're talking about using the same software. And of course, lastly, we have maintenance. So we have aspects of maintenance that we have to consider. We have modularity. Do we have one big system that really can't get broken up, or no aspects of the system depend on any other aspect of the system? Or do we have a system where a module could be swapped with something similar? So sometimes you might think of your system, if you have an entire system, this entire system here might be made up of all these parts that interact with each other, right? So we have all of these modules that let's say are connected. So, part one could swap with part two, could interact with part three, could work with part 4, 5, and 6. And this is where data runs along. And let's say, for instance, our system requires us to change some aspect of module 2. And we have to build a whole new module, right? So this is now 2.a. Is this system able to just swap out, and with 2.a being new, it should, a system with good modularity, we should be able to put in this new module, and to the user, it feels like nothing ever changed, but we just got more, we got more functionality. Or is it that if I change, let's say, sorry, wrong thing. If I change module 5 to something new, 5A, now 5A cannot interact with 6. All right, we might have some problems there. So maintainability. how easily can any one of these individual modules be maintained? Do I have to shut down the whole system to do a piece of maintenance? Yes, Hazard.
So you could explain the first point again, please, when you're talking about modularity.
Modularity.
So
Right.
modularity.
Right. Modularity is just essentially just like what we did last year with the functions. You're breaking the system up into modules. And so the modules, each module will have inputs and outputs. And you want to be able to swap out a module or improve a module or even add a new module, right? So we could even add a new module as well into the system without affecting the rest of the system. That's basically what modularity is. But if your system is not designed properly, an update or a change or an addition can cause you to have to now, make a change in some other aspect in some other aspect or some other module. You with me? Hazard?
Yes, sir, thanks.
Right. And maintainability is when you get inside the modules, how much work or how easy it is or how much disruption you would have to cause when you are changing or updating something on the system. How flexible is your system, right? All of these kind of speak to the same things. How scalable is your system able to grow? So, a lot of times when persons build a piece of software, you're not just building it for now. You might say, okay, I'm building the software. Initially, we know that we might have 10,000 operations per day on the software. But we expect that once people adopt using this software operation, that the system should be able to handle up to 150,000 operations before we start to see any indication of any sort of problems on the system. So you're building your system to say, okay, this is what it is right now, and this is what it could be in the future. That's scalability, right? And an example of that is you see a lot of talk of scalability in cloud computing. So let's say, for instance, Joshua, you developed an app for people's phones. What you do in cloud computing is that you might say, okay, you don't have the resources at home to host this application. But what you can do is that you could contact like Amazon Web Services or Microsoft Azure, and you take a plan from them. And you say, what this plan is that this plan is going to give me X amount of resources. But I don't want X amount of resources alone, because if I only take X amount of resources, if the requirements of my users meet that, I don't want users being denied service. So I might take a plan that says I am guaranteed and I'm paying for X amount, but automatically I could get up to the next tier, even if it is, let's say I have 2 busy days per month. Otherwise, so on a normal month, right? On a normal month, my system, let me get a better color, right? My system might run to this dotted line here, to this dashed line here. But for a couple days every month, because of how my system is, so this is me on monthly, and then near month end, my system goes to there, and we get that. So this is my point X here. I don't want that, this is 2 days every month, eh? This is 2 days every month, this is another day every month. But the rest of the time, I'm always at this. I don't want that during these times my systems fail. So what I do is I just simply pay for the excess whenever that occurs. But otherwise, I'm always guaranteed up to this level here. You understand what I'm saying? And that is thinking about scalability. That is what gets done in cloud computing, right? So your system isn't really ever going to fail, but your system, the way whatever platform your system is running on is flexible enough to deal with periods, even if it's short periods, of increased demand without your user ever having to know that we have problems. Because think about it like this. For most of the year, sites like Amazon have a certain amount of usage. People order stuff off of Amazon every day. But certain times of the year, being Black Friday and Thanksgiving and Christmas, there are times when performance is going to have to spike. Amazon doesn't want to lose anybody's orders. So during those times, their systems automatically expand to be able to handle that increased demand. And that is what that scalability, building with that scalability in mind is for. Okay, it could be temporary or it could be a steady incline in terms of, okay, when my project started or when my application was launched, we had 10,000 users daily. Now we have, 12,000 users daily. In 2 years, we project that we might have 18,000 users daily. You understand where I'm coming from, Hazan?
Yes, so it's like CXC website, like when people are accessing results, everybody on the system does crash. So yeah,
Yes,
yes,
that is a perfect example. And CXC knows this yearly. So CXC can take some sort of system. I don't know why they don't. Maybe they don't want to spend the extra money for those little periods of time. But CXC can pay the extra money and ensure that when the demand is required, that their system is it expands. But maybe at the point at which when CXC started, CXC decided to invest in a certain amount of infrastructure. They're not using a cloud computing company. So their capacity is limited. And you see what it comes back to that point of cost. Because now it's going to cost more money for CXC to have to either move their platform from what they initially invested in, the hardware that they own, to a cloud computing, because what are they going to do with the hardware that they own? So now you're thinking to yourself, okay, I know that whenever results come out, there's going to be a 2-week period every year where we frustrate people. Or should I make the change? It's going to be an expensive investment. What CXC might have to do is just, go to the end of life with their hardware. And then when they are now investing or building again, they have to take that into consideration. So they might move to a newer system at some point. But right now, the moving or making a change or investing more just is not justified for the initial cost that they put into it. Any questions? We'll pause here for today. Any questions related to this before I stop recording? No? All right, so I'm going to stop recording.